Okay, so imagine this. You're standing in the middle of the desert, under the blazing Egyptian sun, staring up at the Great Pyramid. It's over 4,500 years old, made of millions of stone blocks, and yet, somehow, it's still standing. How did they pull this off without cranes, trucks, or even steel tools?
That's the question, isn't it? Because when you think about it, everything about the pyramids seems impossible. The size, the precision, the sheer logistics of moving and stacking those stones, it's almost like they were working with some kind of secret technology.
But here's the thing. There was no secret technology. The tools they used were real, physical, and surprisingly simple. Copper chisels, wooden sledges, dolerite pounding stones. Nothing fancy, nothing futuristic. And yet, they managed to create something that's lasted longer than most civilizations.
Right? And that's what makes this story so fascinating. It's not just about the tools themselves, but how they used them. The ingenuity, the organization, the systems they developed. It's all part of the bigger picture. So let's break it down. What exactly were they working with?
During the Old Kingdom, when the Great Pyramids were built, the Egyptian toolkit was pretty minimal by today's standards. They had copper chisels and saws, dolerite pounding stones, wooden mallets, plant fiber ropes, wooden sledges, measuring cords, plumb bobs, and wooden levers. No iron, no steel, no powered machines. Copper was their main cutting metal, and compared to modern steel, it's soft. It bends, it dulls quickly, and it deforms under pressure.
But somehow it worked. Against limestone, which made up most of the pyramid cores, copper was effective. Workers would shape the blocks directly in the quarry using copper chisels. And when the tools dulled, they didn't just toss them out. They reheated them, hammered them back into shape, sharpened them, and put them back to work.
Exactly. Tool maintenance wasn't just a side task, it was a constant process. Entire teams were probably dedicated to keeping those tools in working condition. But limestone was the easy part. Granite, on the other hand, was a whole different challenge.
Oh, definitely. Granite is much harder than copper, so a copper chisel would have been useless. Instead, they used dolerite pounding stones, heavy, rounded stones that were harder than granite itself. By repeatedly striking the granite surface, they could gradually crush and shape it. It was slow, physically demanding work, but it got the job done.
And we know this because archaeologists have found these dolerite pounding stones at quarry sites near Aswan, often lying right next to partially cut granite blocks. The marks they left behind, shallow depressions and impact scars, match exactly what you'd expect from this technique.
But shaping the stones was just one part of the process. The next big challenge was transportation. How do you move multi-ton stone blocks across the desert without wheels?
That's where the wooden sledges come in. Relief carvings from tombs show massive statues being pulled on sledges by teams of workers. And in one famous scene, there's even a man pouring liquid in front of the sled runners.
That detail is so interesting. Modern experiments have shown that slightly wetting the sand reduces friction dramatically. The moisture creates temporary cohesion between the sand grains, making it easier for the sled to glide. It's such a simple solution, but it's incredibly effective.
And it wasn't just about the sledges themselves. The entire system was optimized. Wooden sledges, plant fiber ropes, coordinated pulling rhythms. Everything was designed to maximize efficiency and minimize effort.
And then there's the question of lifting those stones into position. How do you get a multi-ton block up to the top of a pyramid?
The most likely method involved wooden levers. By placing a long wooden beam under one edge of a block, workers could lift it incrementally, inserting small stones underneath to gradually raise it higher and higher. It's the principle of mechanical advantage, repeated over and over.
And let's not forget alignment. The Great Pyramid is aligned to true north with astonishing precision, and they didn't have lasers or GPS to help them. They relied on observation, watching the stars, using sighting rods, and applying careful geometric layouts.
They even used trenches filled with water to establish perfectly level horizontal planes. It's incredible how much they accomplished with such simple tools and techniques.
But here's the thing. There are still moments where you stop and think, wait, how did they do that? Like the granite sarcophagi with interior chambers that are so flat they seem machine-made, or the drill holes in hard stone with visible spiral grooves, or those diorite stone vessels, thin-walled, symmetrical, almost impossibly refined.
Those are the anomalies that spark debate. Copper chisels can't efficiently cut granite or diorite the way modern steel tools can. The commonly accepted explanation involves copper tubular drills combined with abrasive sand, usually quartz. The copper doesn't cut the stone directly. Instead, the quartz sand trapped between the tool and the stone does the grinding.
And experimental archaeology has shown that this method works, but it's slow, painfully slow. Achieving deep, clean drill holes requires consistent pressure, steady motion, and hours or even days of work. Yet some core samples from ancient drill holes show these incredibly tight, regular spiral striations. The grooves are so consistent that some researchers argue they imply a feed rate that's hard to achieve with simple handheld drilling.
Others suggest that weighted drilling systems, operated by teams, could maintain stable downward pressure. A suspended weight combined with manual rotation might produce far more consistent results than we'd expect. It's a debate that's still ongoing.
And then there are the polished granite surfaces inside certain chambers. To the naked eye, they look machine-finished. Light reflects smoothly, edges are sharply defined. But when measured with modern instruments, you find small irregularities. They're not perfectly flat by today's standards, but they're undeniably precise, given the tools we think they had.
This is the tension at the heart of the debate. If we underestimate ancient skill, we risk assuming that simplicity equals incapability. But if we overinterpret anomalies, we risk projecting modern expectations onto ancient craftsmanship. The evidence we have, copper tools, pounding stones, abrasives, explains a lot. But does it explain everything?
And that's the big question. Archaeology preserves selectively, stone survives, gold survives. But wood, rope, leather, those materials decay. Entire categories of tools could vanish without a trace.
Exactly. Construction sites rely heavily on temporary structures, scaffolding, support frames, lifting platforms. Most of these were made from wood, and after thousands of years, almost none of it remains. We know this because of rare exceptions, like the wooden ship found buried near a pyramid complex, preserved by desert sand.
So it's entirely possible that some tools are missing from the record. Wooden lifting frames, multi-line pulleys, temporary ramps reinforced with mud brick, none of these require advanced metallurgy. They just require materials that don't survive.
But caution works both ways. While organic tools may be missing, there's no evidence for hardened steel gear systems, powered rotary devices, or complex mechanical cranes in Old Kingdom Egypt. The gap is real, but it's not unlimited.
The most responsible position lies somewhere in the middle. Some tools are lost to time, but claims of advanced, unknown technology require evidence that hasn't been found. The real mystery isn't advanced machines, it's the incomplete survival of ordinary engineering materials.
And that changes everything. Modern society associates precision with machinery. We assume complexity in outcome must reflect complexity in tools. But ancient builders maximized simple mechanical principles. A lever multiplies force. A ramp reduces lifting energy. A sledge distributes weight. None of these are impressive on their own, but when scaled through intelligent systems, they become powerful.
Imagine thousands of workers divided into specialized teams, quarrying, shaping, transporting, building. Each group refining their technique through repetition. Time wasn't measured in quarterly budgets, it was measured in decades. When labor was abundant, authority centralized, and cultural motivation absolute, the limiting factor wasn't tool sophistication, it was organization.
And maybe that's the most underestimated tool of all. Structure, hierarchy, repetition, knowledge transfer. The stones remain. The quarries remain. The tool marks remain. And what they collectively demonstrate isn't evidence of impossible technology. They demonstrate what happens when simple tools are scaled through intelligent systems.
So maybe the real marvel of the pyramids isn't just that they were built, it's that they were built by people who understood how to amplify their efforts, not through machines, but through each other.
And that's a legacy that's just as monumental as the pyramids themselves.